Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve a gate question which was asked in the year 2015 for 1 marks. And this question is related to process state diagram, that is life of a process, right? So let us read this question. So the question is asking that the maximum number of processes that can be in ready state for a computer system with n CPUs is, and your options are n square, 2 raised to the power of n, or independent of n, right? So basically what this question is saying is that there is a computer system which has n CPUs, right? And the question is asking that then what is the maximum number of processes that can be in the ready state, right? So let us try to solve this question. So for this I have taken a hypothetical example, right? So here you can see there is a computer system which has n CPUs. This is the operating system, and let's say the number of processes is m, right? So we want to get the maximum value, like what is the restriction on m, right? So let me repeat this for you. The number of CPUs in the system is n, and the number of processes is m. So the question is asking is that what is the maximum possible, like is there a constraint on m, right? On the number of processes that can be in the ready state, right? So this is a condition that these processes should be in the ready state. So as you can see, uh, the number of CPUs and the number of processes that want to execute on the CPU is not related at all, right? So basically, there can be a system with a given number of CPUs, and the number of processes that will be that you can launch in such a system, that is not really related to the number of CPUs, because the number of processes can be less than the number of CPUs, equal to the number of CPUs, or it can be more than the number of CPUs. So here I'm talking about the number of processes that are in the ready state, right? So if it is less than the number of CPUs, then less or equal to the number of CPUs, then there is no problem, right? All of these processes can be scheduled on the CPU. And if the number of processes is more than the number of CPUs, then we have the concept of time sharing, in which the operating system shares the CPU resources among the different processes, right? It allows each process to run for a brief period of time and then switches the control of the CPU to some other process. In this way, it ensures that all of the processes in the system get the CPU time. So it really does not matter how many number of CPUs are there. The number of processes that can be in ready state is actually independent of n. And the only restriction actually there, which is there in the computer system, is on the number of processes that can be in the running state. So if there is a CPU, if there is a computer system which has, let's say, one CPU, then at any given point in time, the number of processes that can be in the running state, that can be only one, at max one, right? Similarly, let's take a computer system which has here 8 CPUs. Then there is a constraint on the number of processes that can be in the running state. At any given point of time, at max 8 processes can be in the running state, right? As such, there is no restriction on the number of processes that can be in the ready state. The only restriction that exists with respect to the number of CPUs is on the number of processes that can be in the running state, right? So if you visit this process state diagram, then we can say that the number of processes that can be running, that is limited by the number of CPUs. That is, if there are n CPUs in the system, then this number is can be at max n. But for the ready processes, the processes that can be in the ready state, there is no as such correlation or restriction with the number of processes in the number of CPUs in the system. So this is independent of n. So the correct option is the last one, that is option D. This the number of processes that can be in the ready state is independent of n, where n is the number of CPUs in the computer system. So guys, this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.